When we were talking about nth roots, we were dealing with x to the power of 1 over n. But sometimes it's not always going to be 1 over n. It's going to be something in the form of m over n. And this is what we're going to talk about and what that means specifically with our exponent. This is what we call positive rational exponents. So like I said, this is in the form of x to the power of m over n. Really, this can be broken down based on our properties of exponents into x to the power of 1 over n to the power of m. This is going to be read as the nth power of the positive nth root. Of x. Again, when we're looking at this, you're really breaking it down into the right side in order for you to simplify it a little bit easier. So for instance, if I have 25 to the power of 3 over 2. So I can actually break this down into two separate exponents. So I'd have 25 to the power of a half, because that represents the 2 in the denominator, to the power then of 3. Well, looking at this, 25 to the power of 1/2, that's really taking the square root of 25. And we know that the square root of 25 is 5. So now we just have 5 to the power of 3. Well, 5 to the power of 3 is 125. So again, what you're doing is you're breaking down that 3 halves. You're pulling the denominator as 1 over the denominator in the parenthesis part, and then you're pulling the numerator number out as an exponent on the outside. And the reason why we're doing that is so we can break down the 1/2 or the 1/3 or whatever it happens to be. So it's a little bit easier to break down. Sometimes the exponent, though, will be applied to a number and a variable. So let's say, for instance, that I have 4x to the power of 8, and that's all to the power of 5 over 2. So what I'm going to do is I'm going to break down that 5 over 2. Okay, so it's going to be 4 technically to the power of 5 over 2 times x to the power, x to the 8th, sorry, to the power of 5 over 2. So now I'm going to break it down into each separate one. So now I've got 4 to the power of a half to the power of 5 times x to the power of 8 times a half to the power of 5. All right, so now that I've gotten that 5 halves broken down, I can actually simplify. So the square root of 4 is 2. So I've got 2 to the power of 5 times. X in this case is going to be 8 times a half gives me x to the 4th. And that's to the power of 5 as well. So 2 to the power of 5 gives me 32. X to the power of 4 to the power of 5 gives me 20, x to the 20th. And that's based on my properties of exponents. So the process is still the same. Just knowing that based on our properties of exponents, that 5 halves goes to the 4 and the x. So looking at that, I know then that I have 4 to the power of 5 halves times x to the power of 8 to the power of 5 halves. And then I broke that fraction down with the 1/2 and the 5 on the outside. After I simplified inside my parentheses, I went ahead and applied the 5 then to give me that 32x to the power of 20. However, there are times when you are asked to solve and not simplify. And what exactly do I mean by that? What I mean by that is I could have, let's go with 32 equals x to the power of 5 6. Okay, so when you're looking at this, it kind of looks scary and you're not exactly sure what to do. However, when you're looking at this, you know that if you multiply your exponents to equal 1, it'd be x to the power of 1. So we need to multiply by the reciprocal. And the reason why is because that 6 times 5 and then this 5 times 6 would give me 30 over 30 to be reduced. So you have to then apply the power of the reciprocal to both sides, because this is going to cancel that exponent out for the x variable. So now we've got 32 to the power of x over 5 equals just a regular x. So now I'm going to break down that 6 over 5. So I've got 32 to the power of 1/5 to the power of 6 equals x. 32 to the power of 1/5 gives me 2. 2 to the power of 6 gives me 64. Okay, so that's something to note, that whenever you have a exponent and you're trying to solve for x, just multiply by the reciprocal and it'll get rid of it. Same thing even if it were like 1/3. You could go through and multiply by 3 over 1 in order to solve for your variable. So this is what you're going to do if you have an exponent that is not a 1 over n, and it's in the form of m over n.